Okay, hello everybody. Today we're going to talk about research. Very, very important. It's also incorporated into history and approaches, but we've already covered that aspect in another tutoring session. So this one I'm just going to focus on when it comes to, hold on, my just research. Okay, and so this one, let me just make sure that I am sharing my screen. Stop. Okay, hopefully it's sharing the right screen. Um, if not, you're looking at my desktop. But anyway, get a new sheet of paper, white paper, preferably no lines, and you are just basically going to be breaking this down, one page summary, into just like how it is here. So we're going to start with the first one, which is psychological research. And basically, we talked about this in class, that the reason why we need research is because we cannot just like boop, just create these conclusions about humans because of these different things that we have. And one of them is what's called hindsight bias, right? It's kind of that hindsight bias is that we believe, like when we get the results or something, or we see the outcome of something, we believe that we knew it all along, right? And so it's like when somebody breaks up, you're like, oh, I knew that was gonna happen. Or, when two, the Heat are playing somebody else, in basketball, and the Heat win, you're like, oh, I knew that was gonna happen. Or if they lose, like, oh, I knew they were gonna lose. We really don't know the results, the end results of anything. We just believe it to be true. Then, of course, there's that overconfidence. We believe that we're a little bit more confident all the time in that we know the correct answer and we know something that's correct, even though, we don't. And then we have confirmation bias. Again, is that we only look for information that support our bias or our beliefs, and then we ignore anything that goes against it. Okay. Now, listen carefully, people, okay? Because this unit is going to be, you're going to have an FRQ just on research, okay? So, scientific method. You need to understand that there's three types of methods of collecting data, right? Or doing research. But all three of them still require a hypothesis. It still requires a operational definition, and it basically still requires some type of, at the end, some type of theory, or that you can replicate it, okay? Specifically with operational definition, because there's a possibility that you could get a question like, what is the operational definition of the independent variable? And operational definition must be observable, and it must be measurable. Okay, so specifically, it must be measurable. Can I measure it? Okay, so let's say if, whatever the case may be, if I want to, let's say here, my hypothesis is that chocolate causes violent behaviors. How do I measure one, like chocolate, like how much chocolate am I gonna give them, and as well as what's violent behavior, okay, and how am I gonna measure that? So from there, we get three types of methods of collecting our information. And the first one, and usually it's what psychologists start with, which is the descriptive method, in which they're going to use, let's say, a case study, right? A case study is a very specific, usually it's only one person, right, that has a really unique characteristics or trait or something, a situation, and they're just going to do an in-depth detail of that person, like their whole life basically is there. They can create a case study with a small number, but again, it has to be really unique. Case studies are great because they are super detailed. They cover a lot. You really get to know, the case study. However, obviously, you cannot generalize a case study. One of the famous case studies here in like Intro to Psych is the Phineas Gage, which is the guy that got that rod through his skull basically, and it affected his behavior. He got more aggressive, his personality changed, and they saw that, well, the frontal lobe has to do with personality and stuff. Obviously, case study, we can definitely learn from that because we all have frontal lobes. But again, it's a case study, one person. Okay, then another way of collecting data, which is really simple, is surveys, right? Surveys are just quick ways of getting information. However, we need to be mindful of the wording effect, because wording effect, depending on what word choices are being made, can affect the results of the survey or the results of the study. So if there's an FRQ that says, oh, they use surveys, right? A survey method, you may want to mention, or they may give you the word like wording effect. How can wording affect this research? And the reality is, depending on what words are used, that could change the results. Okay. And then we have, good thing with this is random sampling, is that they can release surveys to a large number of the population. But again, they have to randomly give those surveys to the people, okay, to the population, whatever they're studying. So if their population is just, let's say, people in high school, it has to be like kids in high school. It has to be all high schools incorporated in the United States, right? Let's say, and then from there they can randomly give to the different schools, okay, the survey. That's why you'll see some research that like they're very, very specific so that their population is a little bit smaller. But then again, the smaller the population, the less you can generalize, right? The bigger the population, if they randomly sampled, then that can be generalized, that information. Then we have what's called the false consensus effect. And this is where we overestimate how much others or share our beliefs or our behaviors. Okay. And that can happen from the surveys. The second one, okay, is naturalistic observation. Naturalistic observation is the one that the researcher does not get involved. They're just observing the subject in their natural environment. Usually this works really well with kids because they're not aware that somebody is watching them. But this is a good, like, a naturalistic observation is, oh, how are high school students during lunch, right? And kind of hiding in the back or watching a camera, right? Of course, getting consent. Okay. Then the second method of, and by the way, so naturalistic, wait, let's go back to survey. So the pros and cons of survey. Pros is obviously you can get a lot of data, a lot of information because it's cheap, it's easy to give it out. The problem is that, of course, people self-serving bias, they like to make themselves look better, right? Why, especially when they're taking these surveys, and people lie. Okay. Then naturalistic observation, it's really good because you get to see the subject in its natural environment. However, there is no, like, you don't understand why it's happening. You don't really interfere with the subject and get to ask them why that happens. Okay. And then the next one is going to be correlational studies. Again, correlational studies also need to have hypothesis, operational definition, okay? This one is different because they are looking to see if two variables have a relationship with one another, okay? That's it. That's all it is. Does one, go with the other? And so from there are, and as you guys know, right, just because there is a relationship does not mean that one causes the other. This does not show cause and effect. Correlation is not causation, right? As you guys should all know. Okay, so there's two types of correlational studies, and they're not, this is not here, but you're going to want to write this down. Positive correlation is when both variables are going in the same direction. So as one variable goes up, the other one goes up as well, right? The more I study, the better I do on my test. Negative correlation is when one variable goes up and the other one goes down, okay? Or vice versa, right? So the more time I spend on TikTok, the less my grade is going to, or even sleep, right? More time on TikTok, less sleep, okay? So those are the the different types of correlation. There's also no correlation at all, which means that there is no relationship between both of those variables. There is what's called illusory correlation, where we believe it's a perception that there's a relationship between two variables, but in reality, false. It does not. So that is that sleeping with your hair wet and getting sick, right? And we talked about all those myths that we have learned. Now, what does it look like? Correlational studies, and I'm kind of going into more of like this measuring data here, but I want you guys to know that if you are doing a correlational study, you need to do a scatter plot, because it's basically looking at these two variables and seeing how they move. So like these little dots are the two variables, and the closer they are, that means the closer the relationship is. So if it's going in this direction, right, which is as one goes up, the other one goes up, that's the positive correlation. If it is a negative correlation, it will look like this, right? In which as one goes up, the other one decreases, or vice versa. Okay, and then if you see something like this, a scatter plot, there is no relationship at all between those two variables. Okay, and then how do we know this? And we know this by what's called the correlational coefficient, right? It's here on this side, by the way, of measuring data. But I would definitely, when you're writing your notes, put it all together. So you're creating a schema and your hierarchies all together in one. So correlational coefficient is the way that we statistically measure a correlation, right? And we said the closer a correlation coefficient is to positive or -1, the stronger the relationship. This just basically tells you the relationship. So if I have a positive, that means it's a positive correlation. And the strength of the relationship is 0.37. This is not really a strong correlation, like a relationship. Your goal is to be at a, and I'm going to write it down, from -1. Oh, hold on. Ah, please hold. Technical difficulties. Okay, I wasn't able to draw, not sure what's going on, but here we have some examples. So just basically so just the closer a correlation is to 0, the weaker the relationship is. And if it's at 0, there's no relationship at all. So if I'm looking at these two things, I have a -0.13, right, or a positive 0.38. Which one of these is stronger? It doesn't matter if it's a negative or a positive. That just tells me what relationship it is. But that's basically, hold on, somebody coming into this tutoring thing, but no. So obviously this one is going to be the stronger one because it is closer to 1 than this one. Then we have negative 0.72 or positive 0.59. The stronger one is going to be a negative 0.72 because it is closer to negative 1. So either negative 1 or positive 1. Okay, if you're not clear on this, please go back to your notes on this. But again, for this one, the answer here would be the negative 0.91 because that is a very strong relationship. Like these two, the 0.38 is the correct answer, but it's kind of like a weak relationship between those variables. This would be a very strong one, and this one would be a very strong one as well. Okay, so that's basically everything that has to do with correlational studies. And then we're going to go to experimental method. And this is the only one that has basically that can give you cause and effect. That one variable will affect the other. Okay? And there's different ways of doing that. One of the first procedures is basically, is it a blind study or a double blind study? Blind study is that the participants do not know what group they are going into, okay? And then, but the scientist knows. The double blind study is that the scientist and the participants do not know what group they are in, okay? And that's just to avoid any experimental bias in there. Then we go into the independent and dependent variable. Okay, the independent variable is basically the variable that they want to see if it changes, right? So what usually happens is that scientists or psychologists, they'll start with descriptive method, right? So they start with, surveys, naturalistic observation, then they move on to correlational studies, right? Oh, I see that if I give candy to students, then they're going to be super active, right? I do this correlational study. I give them candy, see what happens, and I see if there's a relationship. If I find that there is a significant relationship between sugar, let's say candy, and paying attention, then I could go into my experimental study, in which now I need to get my independent variable, which is what I had in my correlational, which was sugar, right, or candy. And I want to see if that's going to affect the a person's attention. Okay, so here, obviously, my independent is the candy because I'm going to manipulate it. And then my dependent is what I am going to measure. Now, make it very clear that when you are doing an experimental, your operational definition is very clear, just like a correlational study. Okay, so operational definition needs to be in all of them. Now, dependent variable is what am I measuring? What is the results I want? Like, how am I going to measure the change? Okay, so for here, it would be the attention. But how do I measure attention? Right, so that would be a little bit not a great one because what makes somebody paying attention? Is it raising their hand or whatever it is? I get to decide that, right? As long as it's measurable and observable. Okay, so that's my independent and dependent variable. Definitely one that will be on that exam. Okay, so independent is your stimulus, your cause, dependent is the effect. Okay, and here it says it, operational definition for both of them. And then, of course, there are what's called confounding variables. As a scientist, as a researcher, you want to control as many confounding variables. Confounding variables are basically any type of variables that can influence the outcome. But you obviously want to try to remove some, remove as many as possible, but that's not always the case. And you need to take that into account as well. Okay? That's why a lot of times that they do these research in laboratories. Okay. So from here, you need to know that, let's talk really quickly about the placebo effect, in which, there's the placebo pill and there's the placebo effect, in which you believe, the participant believes that they're getting some form of treatment and it's going to work, even though they're not getting anything. Okay? And the people will act like if it really is. Okay, so then we have, I will talk just briefly about random selection is that they're getting, like, everyone has the same likelihood of being picked from the population, essentially, right? There is what's called the representative sample, which is what your population that you want to study, basically. Now, when you get to a research or an experimental study, you're going to need to have two groups. You're going to need to have your experimental and you're going to need to have a control. Sometimes you have a lot of experimental groups, but one control. Okay? The control gets nothing. Or sometimes it may get a placebo pill, or they're told something that's not what they're studying, right? An experimental is the group that is getting the independent variable. All right. And then to make this a valid research or experiment, is you must randomly assign the participants to the groups so that they all have an equal chance of being in the experimental or the control group. Okay? They need to be able to randomly assign that. We talked about, let me see, what else is next? I think that's pretty much it when it comes to this. And of course, experimental method is the only one that can give you a cause and effect. This is also the one that when we are given, let me just go very quickly, when it comes to statistical significance, because we keep on seeing that, really the only one that can give us statistical significance is experimental research, right? Because they're the ones that are really seeing if the variable is the independent variable will affect the dependent variable. And so if something is statistically significant, it means that the results are due to the manipulation of the independent variable, right? The results are due to the manipulation of the independent variable. And however, there is a 5% chance that the results are due to chance, okay? That is why they only want a p-value of 0.05, which means that there's a 5% chance that the results are due to chance. But there's a 95% chance that they are due to the manipulation of the results. The manipulation of the independent variable. Miss Lomana might be a little tired. Okay, it's getting a little late. All right, let me just talk briefly about the different ways of measuring data. And we're going to start with central tendency and measures of central tendency. Central tendency is the middle, okay? And that one is mean, median, and mode. And oh goodness, guys, I was checking those FRQs, and again, some people are still having a difficult time with this. The mean is the average, which, what do? You grab all those numbers, you add them up, and divide it by how many they give you, okay? So if they give you 5 sets of data, of numbers, you add them up, divide it by 5, and there's your mean. That's your average. The median is another way of getting the, sorry, getting your average, and this one would be ordering all the numbers from least to greatest, and then you're kind of like going from like from here to here, and then kind of jumping till you get to the middle. If there are two numbers like there is here, then you need to get the mean of those. You add them up, like here, divided by 2, and there's your median, which means that's kind of like the middle number or the middle average throughout the scores. And then the mode is the data, the number that appears the most. Okay, and if you look at these mean, median, and mode, they're pretty accurate because they're near each other. Now I know that my central tendency is accurate because they're near each other. If I see that my mean and my median are really out there, that means that there's a skewed result. Like there may be a little bit of a skewed result here because I'm at 140 and the rest are 160. Okay. So that's our mean, median, and mode. I'm gonna go really quickly to the different um like the graphs. This is the histogram that it goes kind of in sequential, like in frequency, that bars are touching each other. This is not a bar graph. A bar graph, and hopefully I have one here, and I don't think I have one, but a bar graph, we just did an FRQ about that. Okay? But the bars do not touch each other. All right, and then we have the measures of variation. How does my data vary, basically? And you have a range, which is you subtract your highest score to your lowest score, and that is how it would be distributed. Or the standard deviation, which luckily we do not need to figure out the standard deviation, but it's basically um, the distance or the average distance between the scores and the mean, like how far the scores are going to be from the mean. Okay, so look here, very important. A low standard deviation indicates that the points are very close to the mean, right? So if I have a standard deviation of 2, that means that my scores are going to be 2 points away from my mean. That's a good thing. Now, if I have a high standard deviation, like let's say like 20 or 30, that means they're going to be further away from my mean. And I don't necessarily want that. I want everybody to have what would be then called a normal distribution of scores, right? So this would be a normal distribution. And we've talked about this in the other one of the IQs or intelligence, that this is your basic one that we typically have. You're gonna wanna know that one standard deviation is 68% of the population or the people will get this. And then 2 standard deviations is 95%. Okay? If there's further questions with this, guys, when we do like the individual tutoring, please let me know. But this is definitely one, you guys have it. You have tons of resources in your notebook. Go into that. This is unit 1. Now, when my data is not at a normal distribution, it's what's called a skewed distribution. Okay? Which basically means that the scores are not near the mean. Okay, so the first one is a positively skewed, and for this one, it shows that there is going to be more lower scores than high scores, right? And then negatively skewed is that there's more high scores than low scores. Okay, and then this would be the normal distribution. We do not want, like here, this would be positively skewed because there are more lower scores than higher scores. Okay, and I think that's pretty much it. When it comes to this, we are gonna go into ethics. They're for sure the FRQ on ethics or any type of um, what's this called? A question, like multiple choice. But for when it comes to animal research, definitely there needs to be a scientific purpose. You cannot treat them in any inhumane way. If they need to, if they're going to be killed, it needs to be not suffering. They cannot suffer or very limited. So that's basically it. When it comes to human research is going to be, and we've talked about this many, many, many times. Please make sure that you guys understand it. But first one is there needs to be informed consent. Very important. There needs to be, if they are a minor, they're getting it from an adult, a legal guardian, and they must be informed, right? So on the side here, you'll see a little bit more information. Hopefully it'll move over. It's getting there. Get a little bigger. Okay, so they need to agree with it. They need to understand what they're getting into. Okay, then deception is, they should not use deception, but if they need to, because if not, it's going to affect the results, then they have to tell the participants that they were deceived and then debrief them of why they were debriefed. Okay. But of course, the deception, very important, cannot cause any distress to the participants. They should not at any time be forced to be part of the research, and that if they want to leave, they can leave whenever they like. Debriefing is another one that they have to, before the study, they need to be told about the results. If they were deceived, this is the time to tell them why. Um, Please make sure, guys, to really understand ethics, because for sure there's going to be many questions on it, but more specifically on that FRQ, they usually do something with the research where there's something wrong with it and they're like, okay, now fix it. So you have to know ethics. So when you're reading FRQs, start thinking of things like that. And again, they cannot obviously hurt the participants physically or psychologically. They either have to be better, like leave the study better, or the same. They cannot get worse. Confidentiality, obviously, the names should not be revealed. If they could use numbers, if like that FRQ that we just did of 2000, I think it was 14, when it was talking about they sent out the names with the scores, the test scores, that obviously they cannot do that, or they can get consent from the participants, but usually they do not send out names. And then I think that's pretty much it. Then of course the confidentiality and so forth. So that is it. Definitely a very important section for to know. And if there's any more questions, then please jot them down and ask them when we meet. All right. So that is it for research.